Let's first look at what a radar pulse looks like and the set of pulses. I want to introduce some definitions for you. Like every other technology, radar has its own jargon, acronyms, and shorthand terms, which are essential to understand. Just like BFF stands for Best Friends Forever, radar has its own language that you need to learn. I want to explain what these terms mean, so we'll go over them quickly. The peak power refers to the highest power within a pulse. Remember, this is the envelope of power transmitted during the pulse. The pulse width contains a complex sine wave of electromagnetic energy, oscillating at a certain frequency. Peak power represents the highest value of power over time, and the pulse width is the duration of the pulse. After a pulse is transmitted, you'll get an echo back from the target. A little while later, another pulse is sent out. The time between two pulses is called the pulse repetition interval, PRI. There may be a set of pulses, 2, 20, 32, 64, or even 1,000, depending on the radar system. The PRI represents the time between these pulses. The duty cycle measures, on average, how long the radar is transmitting versus how long it's off. It's calculated as the pulse width divided by the pulse repetition interval. The duty cycle tells us the fraction of time the transmitter is active. The average power is calculated as the peak power multiplied by the duty cycle. Another key term is the pulse repetition frequency, PRF, which is the inverse of the pulse repetition interval. For radars that continuously transmit, the pulse length is constant and the duty cycle is 100%, meaning the radar is always on. To give you an idea, while these numbers vary between radar systems, here are some examples of typical values. That's a reasonable example for a radar. You could have a peak power of up to a megawatt, or more or less. Pulse lengths can vary, often around 1 or 2 microseconds, but the target return is typically very small. It can be as little as a microwatt of power. After you turn on your transmitter, it's important to ensure that none of the transmitted energy leaks into your receiver while it's active. The time between pulses can be in the kilohertz or milliseconds range. Pulse repetition frequencies can go as high as 100 kilohertz, 10 kilohertz, 1 kilohertz, or several hundred hertz. These are the typical orders of magnitude for pulse repetition frequencies. Pulse repetition intervals can vary from fractions of a second to microseconds, depending on the radar. For example, some radars operate at 500 to 600 hertz, while others might operate at 80,000 or 90,000 hertz, and we'll explore why later. In this example, the average power is 100 kilowatts because the transmitter operates at a 10% duty cycle. Sometimes the duty cycle is as low as 0.1%, and in other cases, it can be 15 to 20% or higher. These ranges give you a general sense of the magnitude of these values, though they can vary significantly.